So a body continues in its state of uniform motion in a straight line or an uniform rotational spinning motion unless compelled by some external force to act otherwise. Okay, we will do some mathematical calculations by using Muhammad Ghiyasuddin Jamshed Alkashi's theorem, which is normally known as Alkashi's theorem or the law of cosine. Okay, so in order to start with the law, we'll first make a diagram. Let's suppose a body is is moving in uniform motion in a straight line from point A to point B and takes time t and travels distance vt in time t. Okay, let's describe this motion from a reference point O. Or let's draw a gravitating mass. Okay, when I say that the body is moving in a straight line motion, then I means that the body is not compelled by any external uh, force like gravity, or the body lies in deep space or matter-free space where it does not get information from any source near or far. Okay, so we will apply Alkashi's theorem. Let this angle be called phi, this angle theta. Okay, let's apply Alkashi's theorem on triangle OAE using Alkashi's theorem on triangle OAB and using angle phi, we obtain, let this distance be r and this distance be r prime. Okay, so r phi v cos phi are constants. Okay, so using the Alkashi theorem with angle, one option of it with angle phi, we obtain r prime square is equal to r square plus v square t square minus 2rv t cos phi. Differentiating both sides of the equation with respect to t, we obtain 2r prime dr prime over dt is equal to, the derivative of r is 0, plus 2v square t minus 2rv cos phi. Call this equation as equation 1. Okay, now we will put the limits and bring point B back to point A. Applying the limits when point B falls on point A. T tends to 0, R prime tends to R. We obtain R dr over dt is equal to R dr over dt is equal to minus RV cos phi. Here we will introduce Tahir angle. Phi is equal to beta. Beta is Tahir angle plus pi by 2. or we can write pi by 2 plus beta. So we eventually obtain this, gives us dr over dt v sine beta. So we obtain our first equation.
So confused.
Okay, now rewriting equation 1, r prime dr prime over dt is equal to v square minus rv cos phi. Differentiating both sides of the equation with respect to t. Again, we obtain dr prime over dt whole square plus r prime d square r prime over dt square is equal to v square minus 0, because r, v and cos phi are constants. So putting the limits again, when t tends to 0, r prime tends to r, b falls on a. We obtain dr over dt k plus r t square r over dt square is equal to v square. So putting the value of dr over dt, v square sine square beta plus r d square r over dt square is equal to v square. D square r over dt square is equal to v square cos square beta over r. Let us call this equation 2. And call this equation 3. So we got another formula, d square r over dt square is equal to v square cos square beta over r, another condition of inertia. Okay, now I will utilize Alkashi's theorem with angle theta. So using Alkashi's again on triangle OAB, but this time using angle theta, we obtain, we have v square t square is equal to r square plus r prime square minus 2r prime cos theta. Okay, differentiating both sides with respect to t, Again, we obtain 2v square t is equal to 0 plus 2r prime d r prime over dt minus 2r d by dt r prime cos theta. Okay, so we obtain v square t is equal to r prime d r prime over dt minus r dr prime over dt cos theta minus sin theta d theta over dt r prime. Applying the limits when t tends to 0, r prime tends to r, b falls on a. We obtain zero is equal to r dr over dt minus r dr over dt minus 0 plus 0. So we don't get anything from this equation. So we will rewriting equation 1. Rewriting equation 4. V square t is equal to r prime dr prime over dt minus r cos theta dr prime over dt plus r prime sin theta d theta over dt. Now differentiating both sides of the equation above with respect to time, again we obtain v square is equal to dr prime over dt whole square plus r prime d square r prime over dt square minus r sin theta d theta over dt dr over prime over dt plus cos theta d square r prime over dt square plus r d by dt r prime sin theta d theta over dt. So we get v square is equal to dr prime over dt square plus r prime d square r prime over dt square. This is minus. So we have plus r sine theta d theta over dt dr prime over dt minus r cos theta d square r prime over dt square plus r sin theta d by dt r prime d theta over dt plus r prime d theta over dt cos theta d theta over dt. This term, when we make b falls on a, this term will vanish because theta will tend to 0. So we will not consider this term, the underlying one. So we obtain v square is equal to dr prime over dt square plus r d square r prime over dt square plus r sin theta d theta over dt dr prime over dt minus r cos theta d square r over dt prime d theta over dt whole square cos theta. Putting limits when r prime tends to r, t tends to 0 and theta tends to 0 and b falls on a, we obtain v square is equal to dr over dt whole square plus r d square r over dt square plus 0 d theta over dt dr prime over dt minus r cos theta tends to 1 r1 d square r over dt square plus r square d theta over d square 1. So we get v square is equal to v square sine square beta plus v square cos square beta, because d square r over dt square is equal to v square cos square beta over r. So this is going to be this minus r d square r over dt square, which is going to be the same as v square cos square beta plus r square d theta of dt whole square. Okay, so we get v square minus v square sine square beta is equal to r square d theta over dt whole square. So we obtain v square cos square beta is equal to r square d theta over dt whole square. So we get the positive v cos beta is equal to r d theta over dt. So this is the fifth equation. So rewriting equations 2 and 5, there of dt is equal to v sin beta and v cos beta is equal to r d theta over dt. We obtain the desired result. So these are the desired results that we are trying to find. Okay, if we use Alkashi's theorem for special case when the angle theta is 90 degree, we have the differential line element in polar coordinates. So dividing by d square, we obtain which gives us now the velocity is equal to ds over dt. So we finally obtain v square is equal to v square sine square beta plus v square cos square beta. So by this equation we see that we have finally been able to connect beta with the differential line element of polar coordinates, meaning that um, the existence and finally the importance of Tahir angle beta has been established in Islamic physics. So let us call this beta as Tahir angle or Tahir field angle. Thanks for watching.